All right, so today we're going to get into our first special quadrilateral, and it is going to be a parallelogram. Let's first define it. A parallelogram is a quadrilateral and what it has with both pairs of opposite sides are parallel. All right, some things to know about a parallelogram. Opposite sides. All right, these are sides across from one another. So they're going to be across the parallelogram. And sometimes this is how we shorthand parallelogram. We put the little parallel symbol and then just write out the word gram. And that means parallelogram. All right, so opposite sides are going to be across from the parallelogram, and they're not going to touch. All right, so opposite sides do not touch. So opposite sides in this case, if you wanted to name them, if you look at this parallelogram here, some opposite sides would be side AD here is opposite from side BC. So those would be considered a pair of opposite sides, and then you also have another set in CD and AB. Those are also opposite sides. All right, opposite angles, they're diagonal from one another. And again, basically they don't touch in either way either. So if you wanted to look at some opposite angles here, D is going to be opposite from B. And then you have another set here in that A is opposite from C. Consecutive angles now, these are angles along the same side. Because remember, consecutive means back to back. They're in a row. So consecutive angles mean along the same side, and there's actually 4 pairs of consecutive angles because there's 4 sides here of our parallelogram. So if you look along this side, CD, if you say the name of the side, CD, well then those are the consecutive angles. So C and D are consecutive with one another, and then you just go around the whole parallelogram along each side. So C is also consecutive with B. You can go along this edge, and that would be B and A are consecutive, and then your last one, A, is consecutive with D. All right, so now we're going to learn some properties about parallelograms, and this is the part where you need to remember these. This is the important stuff. So what happens if it is a parallelogram? We already know, because of the word parallelogram, kind of the base definition is that both pairs of opposite sides are parallel. Well, also, if it is a parallelogram, then the opposite sides are also congruent. And so basically, we're going to mark whatever the property is that we're discussing. So we're going to say opposite sides are congruent. So A and D are opposite sides. And then also we have AB and DC are opposite sides. So opposite sides are congruent. So now we can use that property to help us find the value of these variables. It's a parallelogram. So again, it's all what's in that name. Remember, this is vocabulary. Geometry is about vocabulary. You have to know that a parallelogram means that opposite sides are congruent. So if this side is 9, that's going to make the other side 9 as well. And here we have B, well, it is opposite from this 11. So if one side is 11, then that side's also 11. So yeah, that one's pretty simple, but once we get a lot of these properties, we're going to talk about parallelograms, rectangle, rhombus, square, and they all have slightly different properties, and you're going to have to be able to remember which one is which. All right, number 2, again, it's a parallelogram. They told us up there. So opposite sides are congruent. So to solve for y in this case, we're going to have to make an equation. So remember, it's all about you are a constant equation creator. But now we just have a new definition, a word parallelogram. And so we're just kind of applying that new concept, but we're still doing the same setup. So x plus 2 is equal to 4. Hopefully I don't make any silly errors like I did on that last one. Sorry about that. Okay, so that means opposite sides are congruent in a parallelogram. Let's look at the next property. So if a quadrilateral is a parallelogram, then opposite angles are congruent. So opposite sides are congruent and opposite angles are congruent. So again, we're going to mark that in our picture. So opposite angles. So D is opposite from B, so we're going to mark those congruent. And A is different than C. So we have here, we have a pair of acute angles are congruent, and then here's a pair of obtuse angles that are congruent. So now let's use that property to help us solve for the value of these variables. And again, it tells us here it's a parallelogram. So now it's your job to know that that means that opposite angles are congruent. So congruent pieces have equal measures. So 4n is equal to 76. Then if you divide by 4, 76 divided by 4, so n is equal to 19. And we were able to do that because they told us this shape is a parallelogram. Let's see, and number 4. We have an expression sitting here, y minus 6, and it has a degree symbol. So I know that y minus 6 should be for this angle here because it's measured in degrees. Well, what do I know about angles in a parallelogram? Opposite angles are congruent. So we're going to set those things equal to each other. So y is equal to 116. Now we still have to solve for x. Well, look where x is at. X is sitting along this side. So this side has the expression of 3x plus 4. It is opposite from the side that has a 16 on it. Well, opposite sides are congruent. So we're going to set the measures equal to each other. So 3x is equal to 12. X is 4. All right, good job. Next one. So now, if a quadrilateral is a parallelogram, then we're going to have consecutive angles are supplementary. And remember what that word supplementary means. That supplementary are two angles that add up to 180. So remember, these are going to be two angles that add up to 180. Consecutive, so remember, now they have to be along the same side. So let's kind of mark this the same as we had in the other picture, that those guys are congruent and these are. So those are opposite angles are congruent. Now what we want to look at are consecutive angles are supplementary. So remember, those are all the ones along the same side. So if you would add up the measure of angle C plus the measure of angle D, you would get 180 degrees. And there, again, you can go all the way around. So angle A, angle D, 180, and you can go along the other edges too. So here along this side, those are going to equal 180 degrees, and along that side. So any angles that share the side are going to be supplementary. Another thing that can kind of help you determine if they're congruent or supplementary is, remember, if they're going to be supplementary, you're going to have one acute plus one obtuse. All right, and they're sharing the same line, so one acute, one obtuse on the same line. That means, ding, 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 that they're supplementary. All right, so one acute, one obtuse on the same line, they're going to be supplementary. So let's use parallelograms. It's a parallelogram to find the measure. Find the measure of angle C. All right, well, all they give us is this 119, the measure of angle D. Well, we know that consecutive angles are supplementary. So if you have 180, you subtract out the measure of angle D. What's left for C is 61 degrees. On to the next, F. So again, this expression F plus 30 degrees means it's for this angle. I have 72 degrees here. So degrees and degrees are the ones I'm going to match up. They have the same units. Well, consecutive angles are supplementary. So let's make that equation. Remember, you're an equation creator. 72 plus F plus 30, they're consecutive. They must be supplementary. Combine your like terms and then solve. So your F is equal to 78. Good job, equation creator. Next, they give me the G. The G is along the outer edge, so it's for this side. Well, if I look here, they give me this expression and then they give me 25. How are those things related in a parallelogram? Well, lo and behold, in a parallelogram, opposite sides are congruent. So there's our other equation. 8g minus 3 is equal to 25. So 8g is equal to 28. So let's see here. We're going to get a little bit of a decimal. That's okay. 28 divided by 8 is 3.5. Great. Alrighty. This one, if a quadrilateral is a parallelogram, then the diagonals bisect each other. All right, so diagonal. A diagonal is a line segment that's connecting things that are opposite from one another. So if we start here at vertex D and we want to draw the diagonal, well, we're going to go opposite from D and we're going to make a segment. So D to B, that's one diagonal of the parallelogram. And then you have another diagonal from A to C. Now you can kind of see there, since the parallelogram is tilted, those diagonals are not the same length. This AD is shorter than this DB. So the diagonals are not the same length, but what happens is the diagonals bisect one another. So this blue line is cutting the red one in half, and then vice versa, the red line is cutting the blue one in half. So again, the whole entire diagonals are not equal to each other. They're just cutting each other in half. So let's see if we can use that. So again, they're telling us a parallelogram. They're giving us some expressions here that are sitting on these line segments. So we have to remember about a parallelogram and what we know about these diagonals. Well, we just talked about the diagonals bisect each other. So this piece, m plus 8, is the same measure as that expression. So we're going to make an equation. Again, it's about definitions. You've got to remember these properties of a parallelogram. This is just our first one. So remember, we're going to add rhombus, rectangle, square, kite, trapezoid. And they all have just a tad bit different properties. All right, 2n minus 1. This expression, what can I relate it to? Well, I can relate it to this other piece because the diagonals bisect each other. So that allows me to create that equation. So n is 5. All righty. So if you just pause it and try the last one and come back and check it. I'm pretty sure you can get it. Okay. This expression 3j here, oh, what can I relate it to? I can relate it to this one because the diagonals of every parallelogram bisect each other. So let's solve. Yeah, we're going to get a little bit of a decimal here. That's all right. Divide by -2. So your j should be 4.5. Alrighty, and k plus 10, that expression, I can set that equal to this one because diagonals bisect each other. Okay, if you're still listening, I want you to draw a big smiley face down here in the bottom corner. So draw a smiley face there. I meant to erase that, and now I can't erase that. This should be a K. So this is K is equal to 2. So draw me a big smiley face. And you have a happy Thanksgiving, or hopefully you had a happy Thanksgiving whenever you're listening to this. I will see you guys later.